this study is about a comparative study of low-emission building solutions. I compared 3 cases from Portugal, Norway, and Czechia. This is just a brief table of contents. Basically, the scope of this thesis was to compare high efficiency solutions for buildings in 3 different countries, and I studied the technical solutions and the context that have some impacts on the solutions, and about the challenges and motivations to apply those. So as you can see here is the Rua do Mar family house. That is the Portuguese case study. Then there is a Norwegian one, which is ZEP Laboratory, and Dřevák, which is a Czech building. It's an apartment building. Just briefly, what is important for this is that Rua do Mar is the reinforced concrete building with infill masonry. ZEP Laboratory is basically all of it is timber and is cross-laminated panels and glulam structure. Just the foundation slab is from reinforced concrete. And Dřevák also uses cross-laminated timber panels, but there are some reinforced concrete components, as well as underground parking, and it's also based on piles. And basically what I was doing was life cycle assessment for Rua do Mar. You can see it's the blue one. I did LCA by myself. There are included all of the stages in the life cycle. Also for ZEP Laboratory, I already obtained the LCA from the stakeholders, and you can see that they only included some of the stages. It's because basically they build it and design it to be ZEPCOM, which means that they wanted zero emission building from construction, operation, and material stages. Which means that they wanted to offset all the impacts, all the carbon emissions from those stages. So what was important for them was material, also replacement, because it's basically material during the use stage, operational energy, and also then it was a little bit on the side. It's not in this assessment, but also reuse and recovery, which is basically, this part is like benefit from PV panels and from recycling. And for Czech building, I also obtained the data from the stakeholders, and you can also see that here they did all of the life cycle stages. What is really important to say here is that the scopes and times of the buildings and times when the LCA was performed was really different for each of them. Rua do Mar is 2012, ZEP Laboratory is 2021, and Dřevák is very recent. It's now in the construction stage, which has very big impact on the results. So it needs to be taken into account when you think about it and when you do the comparison, because the results can differ a lot because of basically these things I've said. Also, what is different here is that in this benefit stage in Rua do Mar family house, here is only accounted for material recycling, which was from certificates from the materials that were used. In ZEP Laboratory, here is only exported energy. So what they got from PV panels for energy and didn't use for the building itself, they accounted in here. And for the Czech case, here is the energy, basically all of the energy they produced on site is here. So that's here are some differences that actually impact the results. I did the contextual study. I did some interviews with stakeholders. In fact, 15 interviews and 2 written ones. There were engineers, architects, policymakers, users, and I was interested what was challenging about buildings and about applying those energy efficiency solutions. Here is the first of the results. It's about the technical solutions. As you can see, it's basically graph of in what stages the most of the carbon emissions were allocated. This is the stage, the D stage, the benefit one, as I talked about before. It's the beneficial one, so it's offsetting of the emissions, and you can see that it's differing a lot. You can also see that in the ZEP laboratory, where they used a lot of PV panels, and also accounted only for the exported energy, they have very big impact. So the offsetting by PV panels is very large. You can also see that in Rua do Mar, it's quite small, but it's also because it was not accounted for. It was accounted only for the recycling of the materials, where the benefits are allocated. Here is in the operational stage, which means that basically what was produced on site was also used on site. So the emissions from operational stage are lower. Also, you can see that in Rua do Mar, there is impact from materials, from basically the construction materials that were used is the, is the biggest impact. And you can see that in the buildings where they focused a little bit more on the material, which was that they used wooden structures. This part is smaller, and energy actually is bigger. So it's you can see the pattern here that basically wooden structures have lower emissions in materials and bigger emissions in the operational stage. Now I would like to talk about a little bit about technical solutions. I would just go through it a little bit briefly, maybe. From all of the countries, all 3 countries, the participants agreed on that early stage optimization is really a key, is the first thing you need to do to optimize the house, because you can, if you optimize the house in the beginning, you can minimize thermal bridges, which was emphasized a lot in the Portuguese case study. And then you can optimize the amount of insulation, and then it also reduces carbon emissions and cost, which was, on the other hand, emphasized a lot in the Norwegian case study. Material selection was more emphasized in Czech and Norwegian case study, where they, as I said, use timber structure. Here is one of the very interesting comparison. It is only from the materials, so it's the big part that I showed you before. I divided it for substructure, superstructure, and roof. What you can see in the first one, in the substructure, it's basically the foundation. Here it's not really surprising, because Dřevák, which has underground parking, it's based on the piles, so the emissions from the substructure are the biggest. So there's nothing really that much interesting. But what you can see in superstructure, and I think that is very interesting, is that ZEP laboratory, they used wooden structure, and you can see that the impact is the lowest out of all of them. But here you can see that Dřevák, which used wooden structure, has almost exactly the same impact as Rua do Mar family house, which used reinforced concrete and inflow masonry. one of the things that it says about the reality of the building structure material is that the wood itself, or the choice of material itself, doesn't mean automatically carbon reduction, as some of the studies suggested, studies that I referenced in my study, was that typology is actually a really important thing in emissions in general. So you can see that in a family house, the emissions are basically very similar as in a residential house that is bigger, that has maybe more walls, and it's just different typology, and it can really have an impact on the emissions. And another thing that that you can see there, or that has impact, is energy mix of the country, because Czech Republic has, let's say, the least renewable energy sources in the energy mix out of all those three countries. So it also has an impact. And also, third thing that plays very big role is that basically, as I said before, LCA was done or performed in different times, and it was performed with different type of information, amount of information, and by different people. So the division of the materials, how it was all grouped, it was just different. So it can also have an impact. And lastly, I would like to talk about truth, because here you can, let's say, finally see that Dřevák, Czech case study, has a little bit lower impact in carbon emissions than Roi de Mar family house. And here you can see basically what I said before, that the materials and the structure, that it's just different, and the materials are grouped differently. This I would say is a little bit more comparable, because in Roi de Mar was used a slab roof, as well as in Dřevák. But in Dřevák it was made of wood, and in Roi de Mar it was made of concrete. So here the type of the structural element is a little bit more similar, so you can compare a little bit better. And then again, you see that in Norway, the Norwegian case study has lower impact again, and that can be also attributed to the fact that Norway has very very big part of its energy mix out of renewable energy. Here is just the summary of the solutions that were used. I talked about some a little bit. I don't think we need to go through it a little bit more. All of them used basically the same solutions, just the motivations were different and the use was a little bit different. Now I'd like to talk about the national and regulatory context that was shaping the solution adoption. And from the study, I found out that those can be divided in 4 groups: climate and comfort, economic conditions, knowledge and construction culture, and legislation. From the climatic and comfort factors, what I think is interesting is the comparison mainly between Czechia and Portugal, where in Portugal, the experience with uncomfortable housing and lack of airtightness and insufficient or poorly designed insulation was more motivating for the people to search for solutions. Whereas in Czech Republic, it was more about buildings getting too hot, and they need to search for the solutions that actually reduce the overheating. So what I think is interesting, that in Portugal, where you think that the climate is warmer, so there will not be problem with being cold and humid, and in Czechia, where it's in winter, it's colder, there you would think the cold will be the problem, but it's actually exactly the opposite. Economic conditions were also in all of the countries, basically, or in Portugal and Czechia, it was pretty big questions, but in Norway, it was a little bit lower because the energy prices are quite low. So it doesn't play that big motivating factor. And also, again, with knowledge and construction culture, it's very important to talk about this problem, because in Portugal just an execution of airtightness remains challenging. Um, and in Czechia, it was again challenging to adopt the wooden structure. So again, the knowledge is always one step that needs to be overcome if it's not something that is already established. But in each country, it was in different area of the knowledge. And also, this is maybe more about the timber buildings, so I will just go through it a little bit faster. That timber is the regulation for fire safety can be hindering for timber structure, because wood is perceived as a high risk material. So that can be something that can legislation make a little bit problematic. But overall, all the participants agreed that one of the important factors in establishing and implementing the measures is actually regulation from European Union, because there is a motivation of people who want to live a little bit more sustainable, or as we talked about, comfortable, but still economic factor is always there. And yeah, sometimes it needs to be overcome by like regulation. Also, what almost all of the participants agreed on is that when you collaborate and share the information, not just the professionals, but also with the policymakers, then it can decrease risks and therefore also costs. So it's also the way how those buildings can become more affordable. Then also I was searching for the transferability of the measures across different contexts. I think this is the word transferability is maybe a little bit sketchy, but because the solutions that were used were actually the solutions that are quite common. They are quite established. Just what was different a lot was the context, was the knowledge, and where the barriers that were that had to be solved. But the solutions are not different. It's just the mindset and level of knowledge, and also climate, and all these things that make together some kind of environment. What is really interesting in here was that in many interviews we talked about with participants, we talked about how actually PV panels are a very carbon intensive solution, and that it actually during the production it produces a lot of carbon emissions. But so I was interested in that. Is it then really worth it to use it, or is it more like that you add a lot of emissions to your building? And as you can see, this gray part is the emissions from the building without PV panels, and this red part is emissions from PV panels. You can see that in ZEP laboratory, where there was used big number of PV panels, the emissions from PV panels are quite higher than in other buildings. But still, if you see the green part, it's basically the offsetting by PV panels, and you can see that even though there are emissions that may be quite significant in the amount of emissions from all the building, the offset that you can reach by that is very high. in Rua do Mar, you can see that it was almost all of the, or very big part of the emissions from the house was offset by PV operation benefit. You can see that in ZEP laboratory there was offset this amount of emissions, and then also it was offset even more from the exported energy. So no matter what climate you're in, the PV panels are really beneficial and can offset very big part of the emissions that you have on your building. As I said, most of the solutions are transferable because they are quite commonly used. But what I would really like to pinpoint here is that Portuguese case and a Norwegian case both used monitoring systems, and it actually made possible to reach the ambitions because the monitoring system found the technical solution that wasn't working as expected, and therefore it was consuming more energy than it was supposed to, and then it was actually it could cause that the building would not actually reach the ambition. For the Portuguese case study, it would be it would use much more energy, and in Norwegian case study where we talked about ZEP ambition, so offsetting the emissions from all those stages, it may not be a reach if they didn't find the mistakes in the working of the technical system. So that's very important factor to consider in the building. So here I would just like to summarize a little bit. We talked about technical solutions, and we found out that passive and active solutions are largely similar, and just the extent of their application and the influential factors differ. To the research question 2, the context shaping solution adoption, we can say it's economic factor and also ownership structure, where I didn't talk about it that much, but who owns the house after it's built is also very important, because if you have the house that is built to sell, then the builder may not be interested that much in the operational stage and in how much money they can save. And also, if you save money, you may also save some carbon emissions because you, for example, use more PV panels, etc. Also, the collaboration and demonstration examples can mitigate the risks. Public awareness and professional guidance increase market motivation because professionals are here the ones who know about the solutions, who know the benefits, and they have to actually present to their clients and guide them through the process. Communication and collaboration is very important, also across the tiers and also with the policymakers and professionals, because when there are legislations and regulations that are made, they need to be made in collaboration with professionals who understand how sustainability in buildings works. And also those are connected also with enabling regulatory frameworks, where just regulation needs to allow for those buildings to be actually possible to adopt them and not be more expensive than others. And also that what is, I would say, maybe most of the important of this is that benefits of applied strategies, for example, material choice, but also some other, are strongly context dependent. It's dependent on typology, on electricity mix, and others. And just about the transferability, as I said, the measures are very much the same. It's just those factors that influence them differ. And yeah, these are just some conclusions for the research. I don't think that's very important for our case study or for the Portuguese one. So yeah, that's all. Thank you for attention.